75 on page 380. I have no idea why it gave me an error there. Okay, so I see something like this. Oops, I want a different color. So I see something like this. Okay, here's our function. Obviously, my graph is far from being perfect. During a diagnostic evaluation, a 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack. Okay, so let's look at the graph. So I follow the graph and I see something like this. Obviously. First question, for which time periods during the diagnostic evaluation was the woman's heart rate increasing? So the function is increasing, that's part A. What will you say? And we have to read from the graph. It was increasing between
the baseline,
between 1 and 4 in minutes. Union between 8 and 10. Do we all see that? We are talking about the trend. We are not looking at the y values. When we talk about increasing or decreasing intervals, we are talking about x. So the function is increasing between time 1 minute to 4 minutes, and it's also increasing between 8 and 10. So 1 and 4, 8 and 10. Do we all see that? Part B, for which time periods was the woman's heart rate decreasing? Very clear from here. F is decreasing between 4 and 8 minutes. Union, 10 and 12. 10 and 12. Part C. How many turning points during the 12 minutes? So between 1 and 12 minutes. Turning points. How many? Exactly 3. 1, 2, 3. Up, down, turning point. Down, up, turning point. Up, down, turning point. 3 turning point. D. Suppose that a polynomial function is used to model. What will be the degree? Minimum. Because you can say degree such and such. It could be. But what is the minimum degree that will work here? If it has 3 turning points.
4.
Exactly. One more. The other way around. Very good. 4. It could have 5. It could have 6. Whatever. But minimum 4. Excellent. This was D. E. Let me scroll down. I can't see the whole thing. Okay. E. For the model in part D, should the leading coefficient of the polynomial function be positive or negative? And we can go back to our table. So we decided the degree is 4. And it has 3 terms. Should it be this or should it be this? Meaning, should it have a positive leading coefficient or a negative leading coefficient? Looking at the graph. Because you cannot have more terms, right, if we consider degree 4. So the leading coefficient should be negative. Finally, use the graph to estimate a woman's minimum heart rate. F. Use the graph to estimate the woman's maximum heart rate during the first 12 minutes. Can anyone estimate the maximum heart rate from the graph? Not from my graph, obviously. Can anyone estimate the maximum?
118.
Perfect. I agree. So F of 10 minutes, 118. The measurement unit is beats per minute. Do not forget the measurement unit. Okay. G. Use the graph to estimate the woman's minimum heart rate during the first 12 minutes of the diagnostic evaluation and after how many minutes. I agree. And after?
8 minutes.
F of 8 equals 64 bits per minute. Very good. So this was an example, a perfect example of what we just studied. This is a polynomial function, degree at least 4. Could be more, but obviously that's what we need, degree 4. And we determine the max and the min. So this is a perfect application of a polynomial function, degree 4. Leading coefficient has to be negative. Good. Now, what do you think we should do? Because I would like to continue if possible, or you may say, no, I want to see another example, I want to see another graph, etc., etc. What would you like to do? Or I continue with refreshing your memory on division of polynomials. Why? It's because we need division of polynomials in the next section of this chapter. How do you feel about polynomial?
I feel okay enough to continue.
Everyone else? Thank you, Samantha. Anyone else would like to see more, or we continue?
I'm good.
Okay. So, any questions on multiplicities? Any questions on the end behavior? Anything? What is new from the previous functions was the end behavior and the multiplicities. And the maximum possible number of terms. I want to say here max. Okay. Good, so let me refresh your memory on division of polynomials. Since we have a little quiz, I'm just going to stop in 5 minutes, promise, at the most. So when we talk about polynomials, division of polynomials, we have two different situations. A polynomial divided by a monomial. Like, for example, x to the third minus 2x plus 1 over x squared. This is a polynomial, and this is a monomial. The other possibility is a polynomial divided by another polynomial. Let me call it q of x, not to be confused with the one at the top. Not monomial. It's not one term. For example, 3x to the fourth plus 2x squared minus 4x plus 12 divided by x minus 1. So let's just look at the first one, this. So here we have the main option is division, long division. Long division. There is another possibility, it's called synthetic division, but this is only, and it works here, only in the situation of a polynomial divided by x minus a number. This works, this is limited. This works always, but this one is limited. The synthetic division is limited to a polynomial divided by 1x power 1 and some number, positive or negative. Okay, so let's look at the first one. So for x squared minus 2x plus 1 divided by x squared, we only have one option, to separate. Separate the fraction and simplify. We don't have long division. This is not applicable here. So the only thing I can do is write x cubed over x squared minus 2x over x squared plus 1 over x squared. That's all I can do. Remember, you cannot simplify. What you can do is separate this over this minus this over this minus plus this over this. And now each fraction will be simplified. Copy the base, subtract the exponents, x. Eliminate 1 from the top and 1 from the denominator. And the last one is 1 over x squared. And this is it. I cannot do anything else. You could say, is this a division? Yes, it is. Now, when we talk about the other one, it's a different story. And we will use long division. I'm going to copy it again. And here's how I copy it. 3x to the 4th. Everything is in descending order. Both of them have to be in descending order, but the top has degree 4. The degree 4 is there. Degree 3 is missing, so I'm going to leave some room. Plus 2x squared. Degree 2 is there. Degree 1 is there. No space needed. Plus degree 0 is there. And divide by x minus 1. Okay. X times what is this? X multiplied by what equals 3x to the 4th. So it must be 3x cubed. I go back and distribute to both terms. 3x cubed times x is 3x to the 4th, but I have to subtract. I have to change the sign every time I write here. Not at the top, but every time I write underneath, I have to change the sign. 3x cubed times negative 1 is negative 3x cubed, but I have to change the sign and write positive 3x cubed under the blank space because I could not pair this with anything else. Perform the operations. 0 plus this is 3x to the 3rd. Bring down the next in line. X multiplied by what is 3x cubed? X multiplied by what is 3x cubed? So it's 3x squared. Positive, we do not lie at the top. Positive 3x squared. I multiply, distribute 3x squared times x, I get 3x cubed. I have to change the sign. 3x squared times negative 1, it's negative 3x squared, but I have to change the sign every time I write underneath. These two make up 5x squared. I bring down the next in line. X times what is 5x squared? X times what is 5x squared must be 5x. We do not lie at the top. Plus 5x. I distribute. 5x to x is 5x squared, but I have to change the sign. 5x times negative 1 is negative 5x, but I have to change the sign. Perform the operations I see and bring down the next in line. Final question. X times what is x? Of course, it's positive 1. 1 times x is x. Subtract 1 times negative 1 is negative 1, but I have to change the sign. And I box in what is called the remainder. So the division of 3x to the 4th plus 2x squared minus 4x plus 12 divided by x minus 1 equals the quotient plus the remainder over the divisor. Quotient 3x cubed plus 3x squared plus 5x plus 1 plus the remainder 13 over the divisor. And you can say, are you sure? And I'll say, maybe not. And I will check. I'll multiply this by this and add 13. So 3x cubed plus, this is if I want to check. 3x cubed plus 3x squared plus 5x plus 1 multiplied by x minus 1 and plus 13. If I do not get the polynomial from the numerator, then I'll say, oops, I have to go back and reassess and do it from scratch. Okay, x, so 3x to the 4th plus 3x cubed plus 5x squared plus x minus 3x cubed minus 3x squared minus 5x minus 1 and plus 13. If this does not equal the top, let's see, this is there. 3x, these have to go away. There is no x cubed. 5x squared with 3x squared, yes, done. Negative 5x plus x, negative 4x, done. And 13 minus 1 is 12, done. Yes. So that is the correct solution.